Hi, this is the second class of manufacturing process, module 1. So last class, we have discussed about basic concept of manufacturing process. What is the difference between cold working and hot working process? What are the main components in a sand casting mold? And what are the steps in a sand casting process? So today, we are starting with types of molding sand. See, in a sand casting mold, the main raw material which is used for making the mold is sand. That's why it is known as sand casting mold. The principal raw material used in molding is the molding sand. And the principal constituent of molding sand are silica, alumina, iron oxide. So molding sand mainly consists of silica, SiO2 86 to 90 percentage, alumina Al2O3 4 to 8 percentage, iron oxide Fe2O3 2 to 5 percentage. With a small amount of oxides of titanium, manganese, and calcium, and some alkaline compounds are also added to increase the properties of molding sand. So molding sand mainly consists of alumina, iron oxide, and silica. Okay. See, basically molding sand are classified into two types: natural sand and synthetic sand. That's the basic classification of molding sand. So natural sand means it is also known as green sand. It is available from natural resources. In the case of green sand, water only act as the binder. And natural sand have the advantage that it has the capability to holding moisture for a long time. So what I mean by natural sand is it is available from nature and water that will act as the binder in the case of natural sand. Second classification of sand is the synthetic sand. Synthetic sand is basically artificial sand obtained by mixing relatively clay and free sand and water and bentonite that act as the binder. So synthetic sand that is prepared artificially by mixing clay and free sand, and the binding agent is water and bentonite. So as here the binding agent is bentonite, synthetic sand have more strength when comparing to natural sand. So natural sand and synthetic sand is the first basic classification of sand, which is used for sand mold making process. So next one, types of molding sand, which is used for sand casting mold making process. So commonly using sand are first one green sand, second one dry sand, third one loam sand, fourth one facing sand, fifth one baking sand, then system sand, parting sand, and core sand. So this 8 classification of sand which is used for making sand casting mold, each sand have its own application. So first one, green sand. See, green sand is a mixture of silica, clay and water. So clay and water that will provide the bonding strength to green sand. Commonly using sand for sand casting mold making is the green sand. Next one is dry sand. See, dry sand are commonly used for large casting. See, dry sands are basically green sand. Green sand is baked and remove complete moisture content will be removed from green sand and forming dry sand. So basically dry sand is green sand. Green sand is baked and remove all moisture from the green sand, then form dry sand. It is used for large casting. Third one is loam sand. See, loam sand is a mixture of clay and sand powder with water to a thin plastic paste. So, loam sand it is available in a thin plastic paste. It is a mixture of clay and sand powder. Fourth one, that is facing sand. That's very important sand. Facing sand. See, this facing sand are usually directly next to surface of pattern, or otherwise this facing sand that will contact with molten metal. So since it is subjected to most severe condition, it have high strength and refractiveness. See, actually this facing sand that will be contact with the molten material. So it will be subjected to high temperature. So it should have high strength and refractiveness. It is commonly made up of silica sand and clay. See, fifth one is the baking sand. See, baking sand is old repeatedly used molding sand. Black in color due to addition of coal dust. See, baking sand are old repeatedly used sand that will be visible as black in color due to the addition of coal dust and burning coming in contact with the molten metal. See, this is a reused sand. Baking sand are reused sand. This facing sand only used for one time. After used, the facing sand will become baking sand. So baking sand not directly contact with the molten metal. It will be below the facing sand. So it will not contact with the molten metal. It should have less refractory strength and it will not have sharp abrasive particles. Due to high temperature, the sharpness of the abrasive particles will be loose and edges will be small round. So baking sand are old repeatedly used sand which is used bottom of facing sand for packing or filling purpose. They are not contact with the molten material and they have no refractory strength. They have no sharp abrasive particles. The sharpness of the abrasive particles are reduced and the sharp edge become small round. Sixth one is the system sand. System sand are commonly used in the machine molding purpose. We have machine folding and manual molding process. System sand that is used in the machine molding process. And seventh one is the parting sand. See, parting sand that have one objective. For easily, first one, it should prevent adhering the molding bosses in parting surface. It will prevent adhering molding bosses in parting surface. And it also provide easy withdrawal of pattern from the sand casting mold. See, when sand casting mold is preparing, we have cope off and drag portions. So cope portion that will be placed over the drag portion. So after the casting has been done, we have to open that. Or when we require to remove the pattern, we have to open the sand casting. At that time, there is a chance that the cope portion and drag portion will be adhered to each other in the parting surface. So in order to avoid that, the parting sand is sprinkled over the parting surface in order to easy removal of the two half. And also the parting sand that will be sprinkled over the pattern surface for easy removal of the pattern. So that's the purpose of a parting sand why we are using. Parting sand or silica sand with a highly sharp abrasive particles are commonly used. Last one is the core sand. See, core sand that is used for making core. See, what is the purpose of a core? A sand casting mold consists mold cavity and mold core. Mold cavity always gives the outer shape of a casting. Mold core that is used to produce hollow casting. See, mold core are always made up of core sand. Core sand means a silica sand mixed with core oil. That is known as core sand. So these are the classification of sand which is used for sand casting mold. So once more, initially sand casting sand are classified into natural sand and synthetic sand. That's very important point. Natural sand and synthetic sand. And types of molding sand are green sand, dry sand, loam sand, facing sand, baking sand, system sand, parting sand, and core sand. So there is a chance that for university examination, you have a question for explaining what are the different types of sand which is used for sand molding purpose. Okay. So we are going to the next topic. This very important topic, that is patterns. So here in this section, you have to understand different types of patterns used for sand casting purpose, and also what you mean by pattern elements and what are the different material used for making patterns. See, first of all, what is the purpose of a patterns? In sand casting molding, patterns are very important components. See, patterns are usually used for forming impression in a sand casting. That's the first purpose of a pattern, which is used for forming impression in a sand casting. Actually, patterns defined as a model of casting. The first step in a sand casting process is making a model of patterns. So patterns are commonly made up of wood or metals. So that is the concept of pattern. So patterns that will be used for forming impression in the mold. Pattern is defined as a model of casting. The first step in a sand casting process is making a pattern. Patterns are generally made up of wood or metals. See, next one, what are the classification of patterns? This is a very important topic. What are the classification of patterns? There are several classification of patterns are available. We can discuss one by one. You have to study all types of pattern, and you have to study drawing all the types of patterns. So I already informed that in this subject, drawing is very important. Sketches are very important. 50% of the mark will be awarded for sketches, almost all question. So whenever you are studying, you have to study drawing sketches also. That's very important point. So what's the classification of patterns? See, patterns are classified into solid pattern. That is the first type. Then split or two-piece pattern. Then multi-piece pattern. Match plate pattern. Gated pattern. Skeleton pattern. Sweep pattern. Follow board pattern. Segmental or part pattern. Last one is loose piece patterns. So you have 10 classification of pattern you have to study. Okay. Suppose it will be asking for a 10-mark question. You have to explain 10 types of patterns. Each carry 1 mark. So you have to write 2 or 3 points and draw the figure for each patterns. So first one, solid piece pattern. So this is a solid piece pattern or single piece pattern. It is also known as single piece patterns. See, solid piece pattern or single piece patterns that are used for very small product that can be easily removed from mold. That's the important point. Solid piece pattern or single piece pattern. These type of patterns are always used for small size product that can be easily removed from sand casting. See, in this type of pattern, the entire pattern is in the drag portion. Entire pattern that is placed in the drag portion of sand casting mold while the mold is making. One surface of pattern is flat, that will act as the parting line. So here you can see that this is a one of the example for single piece pattern. So single piece pattern that is used for small size product. It can be easily withdrawn from the sand casting mold. In the case of single piece pattern, while the mold is making, the entire pattern is placing in the drag portion. And one of the surface of the pattern is a flat surface that will be act as the parting line surface. Okay. Second one is the split pattern or two-piece pattern. See, split pattern means You can see this is a split pattern, one of the example for split pattern. See, in this type of pattern, the pattern is split into two half. The pattern is split into two half. You can see this is the one half and this is the another half. So one part is contained in the drag and another part is contained in the core portion. And there is a split surface. That surface will act as the parting line of the mold. Two half of the pattern should be aligned properly by making use of double pin, which are fitted to the top half. So in this type of pattern, split piece pattern, it is also known as two piece patterns. So the pattern is made in two piece. This is the one piece and this is the second piece. One piece for core portion and another piece for drag portion. And there will be a flat surface that will be act as the parting line or parting surface. And these two pieces are aligned by using double pin that is fitted in the core portion of patterns. Okay, so that is known as split pattern or two-piece pattern. Third one is the multi-piece pattern. So this is a figure of multi-piece pattern. See, multi-piece pattern are commonly used for complicated design and it is very difficult to remove from the sand casting mode. So in the case of multi-piece pattern, the pattern is split into more than two. One for core portion, one for drag portion. So when we are using a multi-piece pattern, sand casting mold consists of a middle portion that is known as cheek. So you can see that this is core portion and this is drag portion. So whenever we are using a multi-piece pattern for a complicated casting, sand casting mold consists three pieces, middle portion. That is middle portion is known as cheek. So multi-piece patterns are always used for complicated casting for easy withdrawal from the sand casting mold. Okay. So this is a figure of multi-piece pattern. So fourth one is match plate pattern. Match plate patterns. So this is a figure of a match plate pattern. You can see this is a figure of a match plate pattern. See, in match plate pattern, patterns are usually made in two half. Patterns are usually made in two half. You can see that this is one half and this is another half. So one piece is mounted on one side of a plate and another piece is mounted on other side of the plate. So one piece, this is mounted on one side of the plate and other piece is mounted on other side of the plate. So gates and risers, runners, gate and runner also attached to one side of the pattern. That means this is one side of the pattern and this bottom portion is another side of the pattern. Gating system and riser is attached to one side of the pattern. Okay, and this plate is known as match plate. That's why it is known as match plate pattern. So the entire pattern is split in two half. One half is attached to one side of the match plate and another half is attached to another side of the match plate. Riser and gating system. Gating system means pouring up sprue runner gates are attached to one patterns, top half of the patterns. So after the molding is completed, when the match plate is removed, after the sand cast mold is completed and the match plate is removed, a complete mold with gating system will be obtained. After the sand casting mold is completed and the match plate is removed, a complete mold with the gating system will be obtained. Commonly using material for making match plate is aluminum. Aluminum is a common material which is used for making match plate patterns. Okay. So fifth one is the gated patterns. See, gated patterns. See, this is a figure of the gated pattern. You can see this is a figure of gated patterns. So these are the patterns. There will be large number of patterns. And these patterns are connected to a common runner. You can see this is a runner. And this is sprue base. And the runner and the patterns are connected by gate forms. So these type of patterns are usually used for mass production of small castings. These patterns are connected by gate forms and a single channel, that is runner, that will supply material to every gate forms. So molten material is flow through this runner and it will supply to every cavity, mold cavities through these gate forms. So these gated patterns are commonly used for mass production of small size castings. Every patterns, so these are the patterns are connected by gate forms, and these gate forms are connected to a single channel, that is runner. And this runner that will supply molten material to the mold cavity through these gate forms. So that's the characteristic of a gated patterns. So what's the main important points of gated pattern is which is only used for mass production of small castings. Okay. So next one is the skeleton pattern. See figure, you have difficulty to understand the figure. You have to make a just idea about why we are using a skeleton patterns. See, skeleton patterns are used for very large casting. Suppose we require only few numbers of casting, not in the case of mass production. And the casting is very large, only we require small numbers of casting. It is not economical to make a large solid pattern. In that case, skeleton pattern is used. So skeleton pattern that consists wooden frames and strips, and the sand is filled inside the pattern, and after that the excess sand that is removed by stick. So a skeleton pattern for a pipe is shown here, almost pipe is shown here. So skeleton pattern, first point you have to remember, skeleton pattern is used for making large size casting, and the number of casting required is very small, and for that purpose it is not economical to make a solid pattern. In that case, skeleton pattern will be using. So in the case of skeleton pattern, the pattern is made up of wooden frame and strips. So once the sand is filled, it will rammed properly, and after that the excess sand will be removed using stick. Okay, that's the purpose of the skeleton pattern. So next one is the sweep patterns. So this is a figure of a sweep pattern. So whenever asking question, you have to draw the figure. The figure is very important, and you have to write 4 or 5 points. That's only required for this subject actually. Figure is very important. That's why I am several times I am saying that in manufacturing process, mission tool and metrology like subjects, figure have very important. 50% of the mark will be awarded to figure for each question. Suppose you are not drawing figure and writing writing, it is nothing, because of 50% of the mark will be awarded for figure only. So you have to study the drawing figure continuously. Okay. So next one is the sweep patterns. So this is a sweep pattern. Actually, this is pattern. This is a pattern, and this is mold. So sweep patterns are used for preparing mold for large symmetrical casting, particularly circular cross section. That's very important point. Why we are using sweep pattern? See, it is used for large symmetrical casting. First point, the casting should be large, and casting should be symmetrical, and casting should be circular. In that case only, sweep pattern will be used. Once more, whenever we are using sweep pattern, the casting should be large, and casting should be circular, and casting should be symmetrical. See, sweep pattern consists of vertical spindle and a wooden template. Outer edge of the template corresponding to contour of the outer edge of the template corresponding to shape of the casting. So sweep pattern means which consists a needle. So this is a needle and a wooden template. Outer end of the template corresponding to the shape of the casting. So this will be fixing in the sand casting mode, and after that the template will be rotating. When the template will be rotating continuously, sand will be swept or removed and the cavity will be formed. Mold cavity will be gradually forming. That's the concept of sweep pattern. So why it is known as sweep pattern is it will sweeping the sand, removing the sap continuously, and the mold cavity will be formed. So that's a concept of sweep pattern. So eighth one is follow board pattern. See, follow board pattern is follow board is a support that is given to the pattern. Basically, follow board is a support that is providing to pattern. If the pattern is structurally weak, you can see this is a pattern. This is the pattern. This shaded portion is a pattern. If I am not using follow board, this is a follow board. If I am not using follow board, what will be happen? Whenever ramming, the follow board will break. The pattern will break. If I am not using follow board, only the pattern is the pattern is a structurally weak pattern. Actually, this pattern is structurally weak. So whenever we are not providing any support to bottom of the pattern, there is a chance that the pattern will break due to ramming force. So in order to avoid that problem, a support will be provided in the bottom of the pattern, structurally weak pattern, that is known as follow board pattern. So follow board patterns are commonly used for a structurally weak pattern. There is a chance that due to ramming, the pattern will break. So there is a wooden support will be provided at the bottom of the structurally weak pattern, that is known as follow board patterns. And the ninth one, segmental or part pattern. See, segmental or part pattern, it is basically a sweep pattern, resemble to sweep patterns. But the difference is that whenever a sweep pattern is rotating, a mold cavity will be producing, complete mold cavity will be producing. But in the case of segmental or part pattern, the mold cavity will be producing step by step. So we have a pivot, and this is a pattern. So it consists a solid pattern. It is founded in a pivot. So one portion of the mold is completed. The entire pattern is removed to another portion and completing them, removing the sand and completing them. So in this way, step by step, the mold cavity will be forming. What is a resemble similarity to the sweep pattern is here also the pattern will be rotating. In sweep pattern also we are rotating the pattern in the pattern with respect to a spindle. So here also the solid pattern that will be rotating with respect to the pivot point. But here what is the important characteristic is while the solid pattern is completely rotating, the mold cavity will not be forming. The mold cavity will be forming step by step. So that's known as segmental or part pattern. Okay, so here also the pattern is rotating with respect to the pivot point, but whenever the pattern is rotating with respect to pivot point, not completely mold cavity is not forming. So after some portion is completing, the pattern is placing to next portion, then again we are rotating and completing the mold cavity. That's the importance of segmental or part pattern. Okay, and last point is loose piece pattern. That's very important one, loose piece pattern. You can see the figure loose piece pattern. Whenever you can see the figure, you will understand, simply understand what you mean by loose piece pattern. This figure itself explains what you mean by loose piece patterns. This figure is very important. Whenever your examination you are writing, this figure should draw very neatly. You will get full mark. I think you will get full mark. So what is a loose piece pattern? See, loose piece patterns are usually used for making an undercut in a sand casting mode. It is used for making undercut in a sand casting mode. So this is the undercut. A single solid piece pattern cannot used for making the undercut. While we are removing the pattern, there is a chance that the sand casting mold will break. So in order to avoid that problem, a loose piece pattern will be used. Do you understand? Suppose we are using a single piece or solid pattern here. Whenever the pattern is removing, the entire mold will break. That's only we are using a loose piece pattern. See, initially, the loose piece pattern is an integral part of the solid pattern. So this is a loose piece. Initially, this loose piece will be always an integral part of solid pattern. After the mold is completed, the main pattern is withdrawn, leaving the loose piece or piece in the sand. These pieces are later withdrawn separately through the cavity formed by the pattern. See, initially, while we are making the sand casting mold, the loose piece is an integral part of the solid pattern. Loose piece that will be an integral part of the this main pattern. So after the sand casting mold has been made, the loose piece will be removing first, leaving the main piece pattern will be removed. That is, the solid pattern will be removed, leaving the loose piece in the mold. Then the loose piece will be removing some sort of method. So this is known as loose piece patterns. So these are the classification of patterns. This is a very important topic. There is a chance that it will be asking for an essay question. So you have to understand to write 3 or more points, and you have to understand to draw the figure of each pattern. That's very important one point. You have to draw the figures. So what are the classification of patterns are solid pattern, split piece or two piece pattern, multi-piece pattern, match plate pattern, gated pattern, skeleton pattern, sweep pattern, follow board pattern, segmental or part pattern, loose piece pattern. Okay. So today I am concluding the section. Class number 2 I am concluding. So today we are discussed about patterns. What is the importance of pattern in sand casting mode and types of pattern. So next topic is what you mean by pattern elements and what are the material which is used for making patterns. Okay. So this PDF note link I will provide it in the description box. You have to download it or you have to study carefully. Okay. Thank you.